Swayam Prabha. Digital India. Educated India.
Okay, welcome to this lecture series on basic surveying. Today we are on module 8, and here we are going to talk about a new method of surveying, which is the plane tabling. We will be discussing this plane tabling in 2 lectures, and we will talk about lecture number 1 today. In lecture number 1, we will try to cover the concept, what are the equipments which we use in the plane tabling, how we work with that, the various steps, setting, leveling, centering, orientation, all these, and then finally to plot details, how we make use of radiation, traversing, intersection methods. Also we will try to see another concept, which is the resection. Okay, let us start with the basic concept of plane tabling. Now when we say this, what is the concept, why we need to do it? Let's revisit some of the things, the basic things about the surveying. One example is, let us say we are going to make a map. If you are going to make a map, what we do, the procedure is, for some area, we would like to establish first of all a set of control. We know about that. Now this control can be established using triangulation or traversing. Now here in this case, we have established the control using traversing. The next, in this area, there may be some buildings. Okay, let us say all these are the buildings here. Also, some trees or other features. Now what our job is, we want to make a map. So having established this control, because we can plot this control now on a map sheet with some scale. Let's say that's the scale. Having done that, here in the field, we can plot these details now by various methods. This method is offsetting. From my traverse lines, I am measuring the offsets at certain chain edges. These are the chain edges, X are the chain edges and the Y are the offsets. If we can do that, we can now mark those chain edges X and as well as the offsets Y and plot the features here in my map. So this is one method. The other method could be taking these 2 points, I start measuring the angles, by intersection. So I am measuring theta 1 and theta 2 and I can locate all the points similarly. There could be many more methods. In the case of the total station, in the first case we are using simply chain or tape for taking the offsets. In the second case, when we are measuring theta 1 and theta 2, we are making use of theodolite. We can also make use of total station. In case of total station, you keep your total station at one of the points and start measuring the objects, because the moment you take one single observation, the total station is taking sloping distance SD, the vertical angle and the angle from azimuth theta. By making use of these 3, as we have seen before also, the coordinates of all the points can be determined, and all these can, by whatever the method, plotted here. So all the buildings and as well as trees and other things can be plotted on our map. So our map will be ready. So what we see here, we are seeing 2 things. Number 1, control. Number 2, filling of details. So in these methods, we are filling the details because we already have a control. Whatever the method, the control has been established by. Now in this filling of details, one thing is very important. The kinds of the instruments which we are using are, as we saw, chain, we are measuring the offsets, or we are using the theodolite, or we are using the total station. Well, there are problems with these. Problems means if you are using offset method, we are measuring the offsets. How many offsets can we measure in the field? There are so many details which we need to put. How many offsets we can measure? And measuring the offsets in the field is difficult. So we have problem there. Then measuring the offsets may not be also very accurate. Well, we can do the intersection by the theodolite, two angles. But the problem is, theodolite is a costly instrument and it's going to take a lot of time. In case of total station also, total station is a very costly instrument. Yes, it can measure the things very accurately. But the problem is, are we going to use a total station which is very, very costly for this purpose? In addition to this, there is one more problem, and this problem we write it as we are making the map in office. What is the meaning of this? There in the field, we are only taking the observations. The observations are being stored inside the total station, or we are recording them. Now, once we are in the office, we make use of those observations and then we make the map. So the ground, once we are making the map, once we are plotting the details, the ground is not in front of us. If there is some problem with the observations, we cannot correct that. Either we have to go to the ground again. So there is a problem like this. Now, can we have a solution in order to avoid this? And that solution is plane table survey. This is also called many times as PT, plane tabling survey. Now, in the case of the plane table survey, what we do, we'll see the methods in a moment, but we go to the field. There in the field itself, we make a map. So it is something like, we are making a sketch of the ground. It's not only the sketch, but it is a sketch in which the geometry of the ground is also represented. So there in the field, we keep measuring the things, we keep plotting them. So in the field, we have a map ready with us. Of course, there are some limitations of this method also, which we'll see in a moment. But it's a very good method because we can fill up the details in the field. The features, the trees, the houses, everything is in front of us. And as they look there in the field, the contours in the ground, the topography, we can plot them as, by measuring as well as by observing them in the field, we can plot them. Okay, now let's have a look at the equipments which we use in plane tabling. The very first equipment which we use in the plane tabling is plane table. It will come with a stand or a tripod. Now let us look at the plane table. This is plane table. As you can see here, we have a tripod. On that tripod, this plane table is fixed. So wherever we want to work in the field, we carry this plane table and tripod with us, and we first fix this tripod. We level the tripod head, and then on top of this plane table is fixed. Having fixed this plane table, I can change the leveling of this. To change the leveling, I can make use of the legs. So I can rotate swing the legs radially or circumferentially also. Having done that, we can level this plane table, and we will see in a moment a little split level which we'll put in the plane table in order to ensure that the plane table is leveled. In addition, this plane table can be rotated, and as well as I can clamp it. If it is clamped, I can't rotate it. It is fixed for plotting. And then on this plane table, as you can see, we have put a drawing sheet here. So a paper which would not shrink with the change in the climatic conditions. We put a paper like that here. and we use that paper for plotting on the plane table. Now we will see the next instrument used in the plane table. The next category of the instrument which is used in the plane table is alidade. We have two types of alidades. One is simple and the other is telescopic. We will see these two alidades now. Okay, over here with us is the simple alidade. As you can see in the simple alidade, we have two veins, and I can erect these two veins. One has a very thin wire here, while on the other side we have a slit. So what we do, keeping this slit towards me and the wire away, I can keep this alidade like this. We keep this alidade on the drawing sheet or on the plane table. I can pivot this alidade about a point. We will see all these things, how these are useful. If I pivot the alidade about a point, let us say, that's the pivoting. Over here it is pivoted. I can rotate the alidade also. The main purpose of the alidade is, using this alidade, I can sight an object. For example, I can sight a tree, and I draw a line here. So, from a point in the plane table, I have a line towards the tree. If I have got some building corner, I rotate this alidade about that pivot. It's rotated, and looking through the veins, the slit and the wire, it is possible now to see the corner of the building there. If I am seeing the corner of the building, again I will draw a line. So what we are doing basically here, using the alidade, we are in fact measuring the horizontal angles, because this table is now horizontal. We have made it horizontal using the level. So on this horizontal plane, we are basically measuring, or rather drafting. Graphically, we are drawing the angle between those 2 points in this horizontal plane. There may be some objects which are, higher, so that I cannot see within the available line of sight here. It may be possible, or there may be something which is down there. In order to help in that case, what we do, we will have one additional thread which will start from top of this vein and will reach the top of this vein here. Now using this extra thread, what I can do, if I am looking downward, the thread here and the wire here, I can bisect the things which are in angular depression, as well as using this thread everywhere and looking from the vein here, I can see an inclination angle or inclined line of sight. So I can bisect objects lower as well as higher and as well as in the horizontal plane. And all these objects can be, we can draw the lines which we say resector to those objects. So the angles between, horizontal angles between all these can be mapped here in the drawing sheet. The other alidade, because this alidade is simple alidade and this one is telescopic alidade. The idea is, over here we have a telescope, as we have already seen the telescope. In addition, we have the straight edge, as in the case of the simple alidade, the straight edge. Plus, using this telescopic alidade, I can also measure the vertical angle in which direction I am looking at. The concept is same. Using this telescope, we use it for accuracy. We use it if the things are, or the objects are very far from us. We cannot see them correctly by naked eyes. So we make use of the telescope. And whatever the angle of the object, we can bisect that. Once the object is bisected, we draw the resector from a point. And similarly, for one point, for the second, for the third, again, we are mapping the horizontal angles between these features which are there in the ground. The next instrument which we'll make use of is rough compass and of course the level. Now let us see what the rough compass is. In the case of the rough compass, as you can see here, we have a magnetic needle and that is encased within a box and it is free to rotate about the point here. So if this rough compass is oriented in the magnetic north direction, this needle will be in the center. Otherwise, it will not be in center. We will make use of this in order to orient our plane table in a moment. So we keep this over the plane table and then we use it. This is the simple split level. We have seen the concept of it. A tube which is part of a big circular tube filled with less viscosity liquid here. So we have a bubble tube here. And using this bubble tube, we'll level the plane table. Well, the next instrument which we use here is plumbing fork and the plumb bob. Now, what is the principle of plumbing fork and plumb bob? The idea is, if this is my plane table, on top of this there is a point. I want to center it. The meaning of centering is, if this point is A and the corresponding point on the ground is capital A, I want to put this plane table in such a way that this small a is exactly on top of capital A, the point in the ground. Now, how to do that? How to realize this? This is realized by plumbing fork. In case of the plumbing fork, what we have an instrument like this, which we'll see in a moment, and from here we have a plumb bob suspended. And the idea of the instrument is that these 2 points of the instrument are along the same line. Well, this is the plumbing fork here. How we use it? We put the plumbing fork like this. Now, wherever the plumb bob is pointing now there in the ground, okay, the same point I can locate here now. So it is a way of transferring that point on the ground over here and the other way around also. A point which is here, a point which is here, where is that point on the ground, just accurately, if you want to do it, a point which is here, that point is there in the ground. So kind of, transferring the point up and down. The last instrument which we will be making use of in case of plane tabling is the tape, because we will very often measure the distances here. So we will also make use of tape. So if you are going to do plane tabling in the field, you should have all these instruments ready with you. Now, having seen these instruments, we will see in a moment the methods, how we do the plane tabling in the field. But we have understood so far, in the case of the plane tabling, we basically make the map there in the field itself. Now, what are the advantages of this method? Number one advantage, as we have seen before also, the ground is in front of us. Whatever is there, we can plot that. So this plotting is, of course, we are carrying out the measurements. It's a measured sketch. It's sketching the ground, but with proper geometry. We do not need to keep any field records. Okay, there are chances that the records may be lost. So that's the main advantage of plane tabling method. Now, disadvantage could be, because we are not keeping any record with us, it might happen that once you are back in the laboratory, something goes wrong with the sheet. We don't have a way in order to regenerate that, because we don't have any records with us. Another problem, when we are working in the field, if the weather conditions are not good, because here we are using a sheet, a paper sheet, and if it starts raining, we cannot work there. Whatever the drawing which we have made or the map which we have plotted, the inks, they will all be washed out. Another problem, when we work with the plane table, you will observe that once you go to the field and work with the plane table, because the paper which is pasted on the plane table, the drawing sheet or the mapping paper, that is white in color. Because it is white in color, so a lot of sunlight will reflect. So it becomes very difficult to work there in the field. So all these are the limitations with this method, but still this method is very good in order to fill details at small scale maps. Now we will see some of those methods, how we do it. Okay, let's look at now that how we work with the plane table. What are the steps? Number one, as we have already discussed, is setting up. Setting up means we bring the plane table at the point where we want to keep it. We put it on the tripod, okay, and we clamp it. The second one is leveling, and we have seen that we will be making use of the split level. And we know the principle of split label. We keep the split label in two perpendicular directions, and we ensure that the labeling is done in both the directions. Once it is so, the table will be labeled in all the directions. The another one, the third one, is the centering. What is the meaning of centering? The meaning of centering is, let us say there in the ground we have 3 points, A, B and C. These are the points which are there in ground. Okay? If I have plotted these points also on a plane table by some method, my A is here, B is here and C is here. I have plotted these by some method. Now I want to carry this plane table, okay, to the point B. The meaning of centering is, when I carry this plane table to the point B, this point, if I highlight that, the point small b should be exactly over capital B. If we can ensure that once this table is brought over here on top of the B and small b is over capital B, that point on the ground, we say the centering has been done. Well, another way, what is the meaning of this? The meaning is the same A, B and C, 3 points on the ground which are plotted on a plane table. All the points which we plot on the plane table, we show them by small letters, while those points on the ground, we represent them by capital letters. Okay? If this table is centered, the meaning is this point B is exactly over the point there in the ground, capital B. So the centering has been achieved. The third step in working is orientation. What is the meaning of orientation? Orientation means, if already some details are plotted on the plane table, we are going to the field, we occupy this field. Besides setting up, labeling, we need to orient it also. Orientation means the way the details are plotted in the sheet, I keep the sheet in such a way that the sheet is oriented, meaning the lines joining any 2 points on the sheet should be parallel to the line which is joining corresponding points there on the ground. We will see this by an example. Well, here is an example of the orientation. If you look here, let us say there in the ground we have A, B, C, D and E. These are the features there in the ground. Okay? And this entire thing is our ground here. And these are the features. Well, we have already plotted this ground, all these points, by some method. So in this sheet, this point is A, this is B, C, these are the points, and D and E. This is A here. And similarly, B, C, D and E. Now this particular map has been done by some method. It may be done by the plane table or by some other method. Or maybe these are the controls which are done by triangulation, total station or whatever. The meaning of orientation is, if I take this sheet to some point here, in between, anywhere. Now in any of these positions, this sheet is not oriented. For example, if I say here, if the sheet is in this position or in this position or in this position, the sheet is not oriented. The sheet is oriented only in this position. Why? Because right now, if I join the line on the sheet joining point A and B, this is A and this is small b, and corresponding to these, the points on the grounds are A and B. So if these two lines are parallel, similarly, we can also see it for point E and point D. So the point E is plotted here, point D is plotted here. If I join these by a line, similarly, I join the points on the ground by a line. Again, these two lines are parallel. So if we are able to put our plane table in such a position that the lines on the sheet are parallel to the lines on the ground, we say our plane table is oriented. Now how we do this orientation? What are the methods? Okay, how to achieve that? How to realize that? The very first method is based on trough compass. We know the trough compass. In the case of the trough compass, we have a magnetic needle, okay, and we keep rotating the trough compass. Once the magnetic needle is in center, it points to the north. Okay, we are making use of the same principle here. Now here in this case, let us say this is the compass. 3 points A, B and C are there in the ground. This is the direction of north here. Let us say these 3 points are already plotted on a sheet. This is our plane table. On this plane table, the C is plotted here, A is plotted here and B is plotted here. Okay, I am again doing it so that it's clear to you. A, B, C are plotted like this. Once we are doing this plot, at the same time, what we did, we also plotted the direction of north on the sheet. So this direction of north is plotted here on the sheet. Okay. Now, if I keep this sheet like this, what we observe, the direction of north here is not the right direction. The right direction of north is this. But the sheet, on my sheet, the north is being shown like this, while the actual direction of north is this. So we can, understand, or rather we can conclude that my sheet is not oriented. In order to orient this sheet, what we would like to do? We would like to rotate this sheet. If we rotate this sheet like this, now the new points have shifted. I will show them by a different color now. The point A is here now, and this is point C, and over here is point B. And now the north of sheet is this, and if the north of the sheet is in the direction of the ground north, and what we have done along the north, which is plotted on the sheet, we have put our trough compass. So there inside is the magnetic needle. So right at this moment, in this case, once this north of the sheet is pointing in the direction of north of the ground, the magnetic needle will be in center. So our sheet is oriented. So from a non-oriented position, the sheet is oriented now. So this is the method of trough compass. Of course, it is not very accurate because this trough compass or the magnetic needle may be affected by not only the magnetic field of the earth, rather it may be affected by some other things, a keyring in your pocket or some other influences or magnetic forces which are there in our surrounding. So it's not a very accurate method, but still for our first approximation, we can use this method of orientation by trough compass. Now what is the second method? Now in the case of the second method, of course, now if we have moved the sheet to a second point as shown here, again we'll have to rotate the sheet and then only the sheet is oriented. Okay, next method of orientation is orientation by backsighting. Now how we do that? Let us say in this case we have some 3 objects A, B and C, they are on the ground. Okay, some 3 features, any. We have a sheet or the plane table here. Now these 3 points are plotted by any method. We are not talking about that. These things will be clear in a moment. In addition, where we are, see, we are also standing on a point on the ground. Let us say that point is X. So that point X on the sheet is small x. Okay, and right now, for example, this sheet is oriented. Right now the sheet is oriented because the lines which are there in the ground are parallel to their corresponding lines on the sheet. Our job is we want to take this plane table from this point x to other point y. Okay, and once we take it to the y, it will be required when we are doing the mapping, we will need to do this. So after taking this sheet which is oriented at x to the point y, again we want to orient it at y, we can do it by trough compass. But the more accurate method will be by backsighting. How do we do that? Well, let us say the y which we want to occupy is here on the ground. From x, by keeping our alley date, so I keep my alley date on the sheet at small x, this point. If I show you the alley date, that's the alley date. Now looking through the alley date, we can see this y and we draw a line or resector. This line or this is called resector. Well, I can measure the distance between these two on the ground, multiply that by the scale at which this plotting has been done, and use whatever this small distance d comes out to be, I can plot the y on my sheet as a small y. So right now what I know? Right now I know on my sheet a direction, a small x, a small y, as well as the location of y. Next, we are taking this plane table to the point y. If I take it to the point y over here, let us say initially my plane table is not oriented. I keep my plane table A, B and C, A, B and C, and the small x is here and small y is here. If I keep my plane table this way over this y, it's not oriented. We want to orient it. So what we do? We keep our alley date at the point y, okay, and we ensure that alley date is kept in such a way that the alley date also passes through a small x. Okay, so on my sheet the alley date is kept at y point and it is oriented in such a way, the alley date, that it passes through a small x. Now there on the ground where this line is, that line is corresponding line is small capital X and Y. Okay, so what I would like to do, I would like to rotate now this plane table so that this line small xy becomes parallel to capital XY. So this is what we are doing at the point here. If I find some space here for the plane table, well, let's keep the plane table here. So the plane table is in the new position. This is small, this becomes a small y now on the plane table. Small x was already plotted. We have kept our alley date at y so that the line of sight passes through small x, and we rotate this plane table till the capital X, because this capital X we can have a ranging rod now. So we keep rotating now our plane table so that capital X is, or the point X there in the ground, is bisected. Once we have achieved this, our small xy line is parallel to capital XY and our table is oriented. So our A, B and C will be in their right position. So what we did, we made use of backsighting in order to orient our plane table. Okay, having seen these two methods of orientation, now let's get into systems in plane tabling. What is the meaning of this? The meaning is, how do we plot details in plane tabling? What do we do in the field? What do we do, when we want to plot the details? In case of other methods, the corresponding methods we have seen, from two theodolites, we can intersect, find the angles, or total station method, or maybe offset method. We use those methods for plotting the details. Now here in the plane table, we want to plot the details. One more thing that we should understand here, in plane table, as we know, in any plotting there are two things. One is control, the horizontal control or the vertical control. The second is details. We want to fill the details. Now, what is the meaning of this? If we have a plane table, the control has been generated by some other method of survey. Let us say if that method of survey is triangulation. So, what we did, we observed all these triangles, and basically we know now the coordinates of all these points. This is how these points have been plotted on the plane table. So, our control is available to us. So, whenever generally we go to the field in order to do the plane table, the control is already available to us. The meaning of this is, on your sheet you have the points which are plotted. These points are already plotted, as well as we can locate these points there on the ground. Now, what we have to do, by making use of these control points, we want to fill the details. How to fill the details? Detailing means we want to plot the tree here, we want to plot the building here, or if there was a road, okay, we want to plot the road here. Now, how to do that? This detailing. This process we are going to look into. Very first method of detailing is by radiation. Now, in this radiation, what we will do, as we can see here, let us say there is some object, a building, and these are the four corners of the object, A, B, C and D, and we want to plot the outline of this building. Of course, there are more corners, we can also locate these. We want to plot the outline of this building. What we do, we occupy a point there in the ground which is P. This point P is the one where we are keeping our plane table. Right now, on our plane table, nothing is plotted. Let us take it like that. Our sheet is blank. Nothing is there on the sheet. In order to plot this big building, because this big building has to be accommodated in my plane table, finally the big building will come like that. If I am standing somewhere here, okay, I am standing somewhere here, the point P, where on the sheet I should be? I should be somewhere here, because what we are seeing, the entire slide here, the full frame of your video is the ground, while this little frame here is the plane table or the drawing sheet. So, if we compare the geometry of this building and this point, so over here the building and the point should be somewhere here. So, once we bring our plane table at a point P, we know where approximately we are. So, that's our starting point. So, what we do on our drawing sheet, if the drawing sheet initially was blank, I mark a point small p. Okay, we are standing at this small p point. Well, this is what we have done. By putting it, we have marked the small p. This is small p. Okay, yes, we are here. Once we have done that, what we do, on this small p, the point which is on the plane table, I keep the alidate, okay, and I rotate this alidate so that I am bisecting one of the corners of the building. So now I am looking in the direction of that corner. Once we have done that, we draw a resector on the plane table. Now this is what we are doing here in the slide. We have drawn a resector to a point capital A. In addition to this, as we discussed that we will also have a tape with us. In this method of radiation, we physically measure the distance between the capital P point, means where we are standing, and the corner of the building A. So this distance is measured. Having measured this distance, what we will do next, we will convert this distance onto the scale. Onto the scale means, how we do that? If S is the scale of the plot, for this map we have decided S is the scale. So, using this distance which is measured on the ground, I can determine the corresponding distance LAP, that means the length on the map sheet. Once I have found it, this is equal to small p and A, we mark the point A here. So, the point A is marked here. Okay. Now, after we have marked the point A, we would like to repeat the same procedure for other points. Well, the point A is now known to us. So, similarly, we draw a resector to point B. We measure the distance between capital P and B and determine the corresponding PB, the map distance, and again we mark the point B. So, A is marked here, point B is marked here on the sheet. Similarly for C and for D. So, what we have done here? Basically, by taking all these resectors and by measuring the distances physically on the ground, converting them to the scale, we are able to mark those distances on our sheet. So, on my sheet now, I have got these 4 points located. Joining those 4 points, I can have the outline of the building. So, here is a small a small b, a small c, a small d, and the outline of the building has been plotted. So, similarly, if we can take more number of points in this building, and the entire building can be plotted. If we had some tree, okay, some other feature, a road, so I can take some points on the road. So, roads, trees, and other things can be also plotted by that method. So, this is the method of radiation. The next method is method of intersection. Now, let's think about it. In method of radiation, what were the problems? The problems were we had to measure each and every distance, and that is very difficult, The ground, many times you may not be able to walk to that particular point. In between, as we can see here, in between this building and our sheet, if we cannot go there, let's say there is a river, a water pond. If that is the case, I cannot measure the distances as we were doing so far. So, if distances are, we cannot measure them, number one, or number two, why should we measure so many distances? More number of distances we measure, more are the chances of the error. Can we do something so that we can eliminate this distance measurement? Okay, that's the question. Now, the answer lies in method of intersection. In this method, we will not measure all the distances, but only one or a few. How we do that? The same, our building A, B, C, D is there. Again, initially, let us say my plane table is just blank. We don't have anything on the plane table. Okay, and I keep this plane table, for example, at a point capital P. So, this point is capital P, which I am recording as small p on the sheet. What I do from here, by keeping my alley date at a small p, I can draw resectors to A, to B, to C, and then finally to D. So, all these are the resectors which have been drawn, the range. Right now, I am not plotting it. In the method of radiation, we had measured these distances also, and then we also plotted those points. In this case, we are not plotting them right now. Well, what we do next, we locate another point Q there on the ground, and towards Q also we take a resector, okay, a resector to the Q. We measure the distance PQ. If we have decided a scale as S, we find the corresponding small PQ, the distance on the map. Using this small PQ, I can locate the point Q here. So what we did, we measured only a single distance right now. Once we have done it, right now on my sheet, what we have, I'm drawing this sheet again. On my sheet, I have a point P, I have a point Q, and then I have some resectors to A, to B, to C, and to D. This is how my sheet will look like at this moment. Well, we bring this sheet, the way the sheet looks like, to the point Q. We center it so that small q is on top of capital Q. We level it and then we orient it also. Now, which method of orientation we'll use? We'll use the method of backsighting, because we already have the things, and using those we can easily backsight our, orient our table by the backsighting. Well, what we do, we bring this sheet over here. Let's say this is the table, the point small p, small q, and then the resectors from Q, from the P. One, to A, to B, to C, and to D. Okay, and while we are doing it, we have already mentioned here that these are the resectors to A, B, C, and D. Well, our table is oriented. We know the method of orientation and we have oriented our table here. Next, what we do, the procedure is same. Keeping my LED on a small q, I sight the point A. So basically, if I keep my LED on this small q and sight capital A, we draw a resector. Let's say this is the resector. Similarly, to B, that's the resector. To C, that's the resector. And finally to D. What we observe? We observe that the resector towards A intersects the corresponding resector at a point over here. Similarly, the resector towards B intersects the corresponding resector which was towards B from P at a point here, then towards C, towards D. So what we have at this stage, we will have our sheet. On this sheet we have small p, small q, as well as the intersection of the points. Okay, this is the intersection corresponding to small a, small b, small c, and small d. So finally we simply join these. Well, I join these, and that's the outline of our building. So in this method, how did we do it? We drew the resectors from both the points. Okay, first from point P, and on our drawing sheet right now only the resectors are there. Then we measure one distance PQ, and we plot the point small q on the sheet. We go back to Q, okay, and then at Q we orient our sheet by backsighting. Again draw the resectors to A, B, C, D. Now wherever the resectors are intersecting, the corresponding resectors, those are the points which are there on the sheet. And so by this, without measuring these distances means the distance from P to A, B, C, D as well as from Q to A, B, C, D. We are not measuring these distances, but still we can plot small a, small b, small c and small d, and our map is ready. So this is a very good method. Using this method, we can make the maps, or rather we can plot the details. The only thing that we should keep in mind, just think of, the triangle here. Think of the triangle P, A and Q. We have already seen, once graphically we have seen it, and mathematically also we have seen it. If two arcs, they are intersecting at 90 degree, the uncertainty is very less. While if these two arcs, they are intersecting at very large angle or very small angle, the uncertainty is more. So the same thing applies here also. Our triangles, for example, like triangle PAQ or PBQ or PCQ, any of these triangles, they should be well conditioned. If the triangle is not well conditioned, we will be locating these points, but error will be more. So this is something which we have to take into account. We have to consider when we are forming these triangles. So our distance from the feature, length of the baseline, how much the baseline is, all these will control what kind of triangles we are forming. So this is an important consideration which we should keep in mind. Okay, so what we have seen today, we saw what is the plane table, the equipments of plane tabling. We saw also the concept, why we use the plane tabling, to fill the details, because the other methods are there, but they are costly, though they are more accurate. Many times we would like to make the maps at very small scale, at a very, without putting much money into that. So plane tabling is a very good solution. Also for some large scale, not very accurate maps, we can use the plane table. Then we saw the advantages of it, disadvantages of it. Then finally, we looked into, how we work with that. What is the system? How to plot the details? By radiation, by intersection. There are some more methods in this, and we'll see those and some other things in our next lecture. Thank you.